March 18th, 1943, Guadalcanal. The humid jungle air hung like a suffocating blanket over the abandoned American position as Lieutenant Hideaki Yamamoto's patrol crept through what had once been a fortified perimeter. The ground squelched beneath their boots, saturated with rainwater and war. Tall kunai grass, broken and trampled from recent conflict, whispered against their uniforms with every cautious step. Shell casings, cigarette tins, broken rations packs, and torn ponchos littered the muddy ground like the remnants of a defeated civilization. Even days after the Americans had fallen back to more defensible positions inland, the acrid smell of cordite still lingered in the air, mixing with the pungent odor of decaying vegetation and distant smoke. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The Japanese soldiers moved in silence, their rifles held tight, eyes scanning for traps or rear guards. But Lieutenant Yamamoto was not looking for enemies. He was looking for answers. Their division had been humbled, not by superior numbers, not by tanks or aircraft, but by something far more insidious: firepower. American infantry squads, despite being equal or even inferior in manpower, consistently laid down volumes of rifle fire that seemed impossible. Their rate of fire, their ability to sustain it, their accuracy, all were unlike anything Japanese infantry had faced in China, Malaya, or Luzon. Something was different here, something profound. Among the scattered debris, partially buried in volcanic soil blackened by rain, Yamamoto saw it. A rifle, unlike anything his men carried. Smooth stock, strangely balanced, heavier than the Arisaka, yet elegant in form. He picked it up, brushing away dirt to reveal a distinctive American marking: U.S. rifle, caliber .30, M1. Below it, the serial number: 3,412,678. Stamped, as if to remind anyone who held it, this weapon was not a prototype. It was mass-produced. It was standard. He felt a chill, despite the jungle heat. This rifle was different. It felt different, and though Yamamoto did not yet understand how, he sensed that this weapon represented more than just American engineering. It represented a doctrine, a philosophy, a mindset. It was crated and transported, hidden within supply shipments, moved through tropical islands, then loaded onto a freighter bound for Japan. Weeks later, it arrived at Kokura Arsenal in northern Kyushu, home to one of the Empire's most advanced weapons evaluation facilities. There, Colonel Takeshi Nambu, nephew of the famous firearms designer Kijiro Nambu, awaited with a team of engineers, metallurgists, ballisticians, and ordnance specialists. What lay on their table would not just be studied. It would be dissected, interrogated, and understood. The engineers recorded their first impressions. The rifle was not manually operated, no bolt to manipulate after each shot, no cycling motion to interrupt aim. It loaded with an 8-round en-bloc clip, an elegant, simple system that allowed quick reloading under stress. No stripper clips, no cycling bolts, no wasted seconds, no interruption of fire. The Japanese weapons team began disassembly. They examined the gas-operated rotating bolt mechanism, a design that harnessed the explosion gases, redirected them through a cylinder to cycle the action automatically. The weapon absorbed energy, recycled it, and turned each trigger pull into a new chambered round. A soldier could fire 8 shots in less than 5 seconds without ever removing their finger from the trigger, all while maintaining sight picture. This was not ordinary. This was revolutionary. The Japanese designers compared it to the Arisaka Type 99, their best infantry rifle. The Arisaka was accurate, reliable, rugged, but slow. One shot, then cycle. One shot, then cycle. In theory, trained riflemen could fire 10 rounds per minute. In practice, under combat, 5 to 7. But with the Garand, a well-trained soldier could fire 30, even 40 aimed shots per minute, and do it walking, kneeling, or from cover, without breaking stance. Worse, what stunned Colonel Nambu's team even more was that this rifle somehow resisted the jungle. The humidity that caused Japanese rifles to rust, the dampness that swelled wood and jammed bolt actions. Somehow, the Americans had designed metal treatments and wood coatings that resisted rot, rust, and warping. The ordnance report would later read, "Their rifle has been built not only to fire, but to survive." That realization shook them. Weeks turned to months. The rifle was tested in rain chambers, salt chambers, mud barrels, high-heat trials. It survived them all. The Japanese team attempted to produce working prototypes based on the Garand system, using available materials. Most prototypes failed. Japanese metallurgy, optimized for bayonets and bolt actions, was not equal to American alloy sciences. Their steels were too brittle, too soft, too heavy, or too expensive to produce in large numbers. And then came the most devastating discovery: production scale. In the United States, these rifles were not rare. They were not elite. They were not reserved for special units. They were standard issue. Every American infantryman, every soldier with boots on the ground carried one. They were producing tens of thousands each month. By some projections, they would soon be producing over 1 million per year, not for paratroops, not for commandos, for everyone. Colonel Nambu's report to the Imperial General Staff was almost poetic in its horror. The Americans have not merely built a rifle, they have built an army around a rifle. He argued, in private meetings, that Japan's infantry doctrine was now strategically obsolete. Empire still believed that firepower was artillery, aircraft, and naval guns. But the Americans had brought firepower down to the individual soldier. One man, one rifle. 8 shots, all self-loading, all fast, all deadly. Japan built soldiers around spirit. America built soldiers around technology. And technology was winning. At a closed meeting in late 1943, Colonel Nambu presented a theoretical model. If 1,000 Japanese riflemen armed with Type 99s fought 1,000 Americans with M1 Garands, equal terrain, equal training, equal cover, the Americans would fire between 4 and 6 times more rounds in the same time period. Even if Japanese marksmanship was superior, they could not compensate for the sheer mass of accurate fire. But the M1 Garand was more than a weapon. It reflected an industrial mindset, a nation that could invest years of research before war, a nation that thought in terms of standardization, not individual craftsmanship, a nation that could afford to experiment, fail, experiment again, and finally produce something truly modern. Japan could not do that, not because they lacked ingenuity, but because they lacked time, steel, fuel, machinery, factories, and above all, doctrinal imagination. Colonel Nambu quietly admitted it to a colleague. "We are fighting the first industrial war of men with farm tools against men with machines." The truth was more painful than any defeat on the battlefield. Japan could not copy the Garand, even if they wanted to. They could study it, they could admire it, they could learn from it, but they could not reproduce it, not without reinventing their entire military-industrial structure, not without abandoning prestige-driven design systems that favored officer swords and ceremonial pistols over infantry rifles, not without disrupting decades of tradition. In December of 1943, Yamamoto was invited to Kokura to view the findings. He held the Garand again, but this time, in the controlled light of a weapons laboratory. He looked at it differently. In the jungle, it had been a trophy. Now it was something else. It was a warning. As he held it, he understood something that most of the Imperial Army did not. Wars were no longer won by bravery alone. Wars were won by engineering. Wars were won by mathematics, by steel, by factories, by design. When he placed the rifle down, he said softly, "We are not losing to the Americans. We are losing to the future." The room fell silent, and, deep in their hearts, every man there knew. The rifle was not just a weapon. It was a message that Japan was fighting yesterday's war, with yesterday's tools, against tomorrow's army, and tomorrow was already here. The recovered Garand arrived at Kokura Arsenal on April the 2nd, transported under armed guard through Japan's increasingly vulnerable transportation network. Bureau of Military Affairs officials had designated the captured rifle as priority intelligence material, recognizing that American infantry firepower had become the dominant tactical factor in Pacific ground combat. Japanese soldiers returning from Guadalcanal, New Guinea, and the Central Pacific Islands reported the same terrifying pattern. American riflemen could maintain sustained fire rates that seemed impossible for manually operated weapons. While Japanese troops armed with the Type 38 Arisaka bolt-action rifle struggled to cycle their actions between shots, American infantry poured semi-automatic fire into Japanese positions with mechanical precision. The captured M1 would either explain this phenomenon or confirm Japanese fears that they faced technological superiority they could not overcome. Colonel Nambu gathered his evaluation team in the Arsenal's secure testing facility at 0600 hours on April the 5th. The Garand lay on the examination table like a technological artifact from a more advanced civilization. Its walnut stock showed the wear of Pacific service, the metal components bore the patina of tropical humidity, and the action still functioned smoothly despite weeks in Guadalcanal's corrosive environment. Nambu's initial inspection revealed design philosophy that challenged fundamental assumptions about infantry rifle development. The weapon employed a gas-operated system that bled propellant gases from the barrel to cycle the action automatically, eliminating the manual bolt manipulation required by the Arisaka. This approach represented manufacturing complexity that Japanese weapons designers had deliberately avoided in favor of simpler, more reliable mechanisms. The Americans had apparently solved problems that Japanese engineers considered unsolvable under field conditions. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Within the first week of examination, patterns emerged that suggested American weapons development operated under entirely different constraints than Japanese design philosophy. The Garand's operating rod assembly required precision machining to tolerances that Japanese arsenals normally reserved for artillery pieces, rather than infantry weapons. The gas cylinder employed metallurgy that resisted corrosion better than any steel Japanese ordnance factories currently produced. Most disturbing of all, the rifle's overall weight of 9.5 pounds suggested American infantry could carry semi-automatic firepower without the mobility penalties that Japanese doctrine considered inevitable with self-loading weapons. The Arisaka, by contrast, weighed 8.8 pounds, while offering only manual bolt-action operation. The Americans had achieved greater capability with marginally increased weight, violating Japanese assumptions about the necessary trade-offs in rifle design. Metallurgical analysis of the Garand's barrel revealed chrome-molybdenum steel composition that exceeded Japanese manufacturing standards even during optimal pre-war conditions. The rifling maintained dimensional stability that ensured accuracy after thousands of rounds, while Arisaka barrels showed measurable erosion after as few as 3,000 shots. American ordnance engineers had apparently prioritized service life and maintained accuracy in ways that required metallurgical sophistication Japanese steel mills could no longer guarantee. Supply disruptions and declining ore quality had forced Japanese manufacturers to accept reduced specifications across their entire weapons production infrastructure. The captured rifle's barrel represented standards that Japanese industry had never consistently achieved and could not hope to match under wartime conditions. The gas-operated mechanism presented the evaluation team with their first clear understanding of how American infantry maintained such devastating fire rates in combat. The Garand's actions cycled automatically upon firing, extracting the spent cartridge case, cocking the hammer, and chambering a fresh round without any manual manipulation by the shooter. This eliminated the physical movements required to operate the Arisaka's bolt, reducing the time between shots from approximately 2 seconds to less than 0.7 seconds for trained riflemen. Over the course of a sustained firefight, this difference translated into American infantry delivering 3 times the volume of accurate fire compared to Japanese troops using bolt-action rifles. The tactical implications were staggering. Japanese infantry doctrine had emphasized marksmanship and individual shot placement, assuming that superior training would offset any technological disadvantages. But the captured Garand revealed that American soldiers wielded weapons that amplified individual capability through mechanical advantage, allowing average riflemen to achieve fire rates the Japanese marksmen could not match, regardless of training or experience. The en bloc clip feeding system initially appeared to represent an American design compromise, perhaps evidence that even United States ordnance engineers struggled with self-loading rifle reliability. The 8-round capacity seemed modest compared to the 5-round internal magazine of the Arisaka, and the distinctive metallic ping as the empty clip ejected after the final shot could potentially alert enemy forces to a vulnerable moment during reloading. However, detailed analysis revealed the clip system to be a sophisticated solution to competing design requirements rather than a limitation. The en bloc clip enabled rapid reloading under stress, requiring only that soldiers insert the loaded clip into the receiver and thumb it home with firm pressure. This process took experienced troops approximately 2 seconds, far faster than the fumbling insertions required to load individual cartridges into the Arisaka's magazine under combat conditions. The Garand's total capacity of 8 rounds also meant American riflemen carried more ready ammunition in their weapons than Japanese soldiers with 5-round Arisakas, extending the time before reloading became necessary. By late April, the evaluation team had begun testing the captured Garand under simulated combat conditions at Kokura's firing range. The rifle's performance exceeded even optimistic Japanese assessments of American weapons capability. Accuracy remained consistent across rapid-fire strings that would have caused Arisaka barrels to heat sufficiently to degrade shot placement. The gas system functioned reliably, despite deliberate contamination with sand, mud, and salt water intended to simulate Pacific combat environments. Most impressively, the Garand maintained mechanical function after firing sequences that totaled over 1,500 rounds across 3 days of continuous testing, a level of durability that would have caused multiple component failures in most Japanese firearms. The reliability testing revealed design features that Japanese engineers had considered unnecessary complexity, but which the Americans had apparently implemented as standard practice. The Garand's gas system included a relief valve that prevented overpressure conditions if the gas port became partially obstructed by fouling. The operating rod assembly employed beveled contact surfaces that reduced the possibility of component binding if dirt entered the action. Even the trigger mechanism incorporated over-travel limiting that maintained consistent pull weight across thousands of firing cycles. Every aspect of the rifle suggested designers who had anticipated field conditions and engineered solutions to problems before they occurred, a development philosophy that required extensive testing and refinement. Japanese weapons programs could no longer afford under wartime production pressures. Comparative analysis between the Garand and the Type 38 Arisaka illuminated the extent of Japanese technological disadvantage. The Arisaka represented pre-World War I design philosophy, a robust, bolt-action rifle optimized for manufacturing simplicity and ammunition conservation. Its action required 5 distinct manual operations to chamber each round, fire the shot, extract the spent case, cock the firing pin, and prepare for the next cartridge. Japanese soldiers had trained extensively to perform these actions rapidly, but even the most skilled riflemen could not approach the cyclic rate possible with the Garand's semi-automatic operation. The American rifle eliminated 4 of the 5 steps required to fire consecutive shots, translating directly into tactical superiority that no amount of Japanese training could overcome. The ammunition employed by each rifle system further emphasized the performance gap. The Garand fired the .30-06 Springfield cartridge, a powerful round that delivered approximately 2,700 foot-pounds of muzzle energy and remained effective at ranges exceeding 800 yards. The Arisaka's 6.5mm round produced roughly 1,600 foot-pounds of energy, adequate for infantry combat, but noticeably less powerful than the American cartridge. Japanese ordnance officers had selected the smaller caliber to reduce recoil and allow soldiers to carry more ammunition, design decisions that made sense within the context of bolt-action rifle limitations. The Americans, operating with semi-automatic weapons that managed recoil through gas operation rather than requiring shooters to absorb full impulse, had retained more powerful ammunition that maximized terminal effectiveness. Every aspect of the comparison suggested American designers who had developed their rifle system without the constraints that limited Japanese options. Production analysis revealed perhaps the most sobering disparity between American and Japanese weapons manufacturing capability. Springfield Armory and Winchester Repeating Arms had manufactured over 4 million Garands by 1943, achieving production rates the Japanese arsenals could not match, even when producing the far simpler Arisaka. American factories treated precision machining as a routine requirement rather than an exceptional achievement, employing tooling and quality control procedures that ensured interchangeable parts across millions of rifles. Japanese weapons production, meanwhile, had been forced to accept wider tolerances and increased hand-fitting as the war progressed. Skilled workers who understood precision manufacturing had been conscripted for military service or reassigned to higher priority programs. Machine tools wore out without replacement as Allied bombing disrupted domestic industry. The gap between optimal manufacturing standards and achievable production capability had widened to the point where Japanese arsenals could no longer guarantee the dimensional consistency required for truly interchangeable components. Colonel Nambu's preliminary report to the Bureau of Military Affairs, completed in early May, acknowledged what months of analysis had confirmed. The M1 Garand represented a generation of weapons technology that Japanese industry could not replicate under current conditions. The rifle embodied manufacturing sophistication that required industrial infrastructure Japan no longer possessed, and material specifications Japanese steel mills could not consistently meet. Even if complete technical drawings were available, replication would remain impossible, given the degraded state of Japanese precision manufacturing by mid-1943. The report concluded, with uncomfortable honesty, Japanese infantry would continue facing American riflemen who wielded weapons fundamentally superior in firepower, reliability, and ease of operation. No tactical innovation or training enhancement could fully offset this technological disadvantage. As spring gave way to summer, the captured Garand remained at Kokura Arsenal, serving as tangible evidence of American industrial capability and Japanese manufacturing limitations. Engineers who had expected to extract useful design features for implementation in Japanese weapons instead found themselves documenting the extent of their nation's obsolescence in small arms development. The rifle that had promised to reveal American secrets had instead illuminated the gulf between two nations' manufacturing ecosystems, demonstrating that victory in modern warfare required not just tactical skill or strategic vision, but industrial capacity to produce advanced weapons at scales Japanese factories could no longer achieve. The psychological impact on the evaluation team had evolved from initial curiosity through growing concern to something approaching resignation. They possessed complete technical understanding of the Garand's operation, could measure every component to sub-millimeter precision, and could explain every design decision with engineering clarity. Yet, this knowledge meant nothing without the manufacturing capability to implement it. The captured M1 had become a mirror reflecting Japanese industrial decline rather than a pathway to competitive parity, proof that technological understanding alone was insufficient when confronting enemies whose factories could translate designs into mass production with precision Japanese arsenals no longer commanded. The recognition that direct replication was impossible forced Colonel Nambu to confront an alternative question. What modifications could Japanese arsenals implement within existing manufacturing constraints to narrow the firepower gap between the Arisaka and the Garand? If Japanese industry could not produce self-loading rifles, perhaps Japanese doctrine could adapt to minimize the tactical disadvantages of bolt-action weapons. The captured M1 would serve not as a blueprint for construction, but as a catalyst for realistic assessment of what Japanese infantry could achieve with the resources actually available, rather than the capabilities they wished existed. Weapons trials conducted throughout May and June explored whether simplified semi-automatic designs might prove manufacturable within Japanese industrial limitations. Engineers drafted proposals for gas-operated rifles that eliminated the Garand's more complex features, substituting simpler mechanisms that required less precision machining. Prototype development revealed the fundamental problem with this approach. Every simplification introduced reliability issues that made the weapons unsuitable for combat conditions. Gas systems that functioned adequately on firing ranges failed when exposed to mud, humidity, and the thermal stress of sustained fire. Operating mechanisms built to relax tolerances jammed when fouling accumulated or when dimensional variations from heat expansion exceeded design margins. The correlation between manufacturing precision and mechanical reliability proved absolute. Japanese arsenals could build semi-automatic rifles, but they could not build semi-automatic rifles that worked consistently under field conditions without access to the precision manufacturing capabilities the war had destroyed. Alternative approaches focused on maximizing Arisaka effectiveness within the limitations of bolt-action operation. Training programs emphasized rapid bolt manipulation techniques that reduced time between shots, though even the most skilled riflemen could not approach semi-automatic fire rates. Ammunition loadout modifications increased the number of stripper clips infantry carried, reducing reload time penalties, though not eliminating them. Squad tactics evolved to concentrate bolt-action rifle fire from multiple soldiers simultaneously, creating brief bursts of massed firepower that partially compensated for individual weapon limitations. These adaptations represented pragmatic responses to insurmountable technological disadvantage, attempts to extract maximum capability from obsolete weapons because superior alternatives remained beyond reach. Intelligence analysis of American infantry tactics revealed how Garand-equipped units had restructured their operations around semi-automatic firepower. American rifle squads attacked with aggressive fire and movement techniques that exploited their weapons' rapid-fire capability. Individual riflemen provided suppressive fire while teammates advanced, creating overlapping fields of semi-automatic fire that pinned Japanese defenders and enabled maneuver. Japanese infantry employing bolt-action rifles could not reciprocate this tactical approach. The time required to cycle Arisaka actions between shots meant Japanese soldiers could not maintain the sustained fire necessary for effective suppression. American infantry could shoot and move simultaneously, while Japanese troops had to choose between shooting and moving, unable to do both effectively. The captured Garand had revealed not just a superior weapon, but an entire tactical system built around capabilities Japanese forces could not match. Metallurgical studies of the Garand's components continued throughout summer. 1943, providing detailed documentation of American materials, science that Japanese industry could observe but not replicate. The rifle's receiver employed steel alloys that maintained strength characteristics across temperature ranges that caused Japanese steels to become brittle or lose hardness. Chrome molybdenum barrel steel resisted erosion from hot propellant gases far better than the carbon steel Japanese arsenals use for Arisaka barrels. Even seemingly minor components like springs and firing pins demonstrated material quality that exceeded Japanese manufacturing norms. American ordnance engineers had built reliability and longevity into every element of the rifle, treating durability as a fundamental requirement rather than a desirable luxury. Japanese weapons designers, constrained by material shortages and simplified manufacturing requirements, had been forced to accept reduced service life and increased maintenance demands as inevitable compromises. Production data gathered from additional intelligence sources delivered an even more sobering realization than anything discovered from technical examination alone. It revealed not only what the Americans had built, but how they had built it, and how far Japan stood from achieving similar capabilities. The captured M1 Garand had shown engineers the design of a superior rifle, but the manufacturing reports showed them the true heart of American military advantage: precision as an industrial doctrine, not an aspiration. American factories such as Springfield Armory and Winchester Repeating Arms operated on the belief that precision was not a goal to be pursued under ideal conditions. It was a requirement to be maintained at scale, under pressure, without exception. Their production lines treated dimensional accuracy not as a fragile ideal, but as a solved and standardized process. Springfield Armory maintained tolerances measured in thousandths of an inch, levels of accuracy that Japanese arsenals considered extremely difficult even during peacetime experimentation, much less in mass production during war. Yet American factories maintained these tolerances not for hundreds or thousands of rifles, but for hundreds of thousands, assembling rifles whose parts were interchangeable across multiple manufacturers without any hand-fitting. This concept, interchangeability at scale, was almost unthinkable in the Japanese system. In the Japanese arsenals, particularly at Nagoya, Kokura, and Jinsen, production of Arisaka rifles had been steadily declining in quality as the war progressed. Machine tools wore down rapidly due to overuse, uneven maintenance, and lack of replacement parts. Steel quality deteriorated because supply lines were disrupted. More significantly, hand-fitting, once a point of pride in pre-war craftsmanship, became not a refinement, but a necessity. As machining accuracy declined, workers had to manually correct misaligned bolt lugs, misfitted chambers, and uneven stock bedding. It slowed production, reduced consistency, and introduced faults too subtle to detect until rifles were in the field, and sometimes even after they had failed in combat. The Americans, by contrast, had created a system where machine precision eliminated the need for hand-fitting. They did not rely on highly skilled craftsmen at every stage. Instead, they relied on process control, standardized tooling, and rigorous calibration. More importantly, when tools degraded, they replaced them, not only because of wear, but because they had the industrial capacity to maintain precision as a constant, not a variable. Winchester's production capability was, in some ways, even more impressive than Springfield Armory's. They produced enormous quantities of Garands while maintaining equally strict quality controls. Parts from Winchester rifles fit flawlessly into those made at Springfield, and vice versa, a feat that required not only precise machines, but a manufacturing philosophy rooted in predictability, replication, and long-term planning. It was industrial engineering applied to military necessity. Japanese analysts, studying these production reports alongside the Garand itself, slowly understood a painful truth. Even if Japan perfectly copied the technical design of the M1, they could not replicate the industrial system that made it possible. They could build one Garand. They might even build 100, but they could never build 100,000 in the same way, identical, interchangeable, durable, and standardized. They could imitate the weapon, but not the system that conceived it. And that system was what truly mattered. Japanese command had entered the war believing that superior spirit, discipline, and combat tradition would compensate for industrial disadvantages. But weapons like the Garand and the manufacturing capacity behind them proved that modern war did not reward tradition. It rewarded systems, not just invention, but replication, not just design, but production, not just accuracy in a prototype, but accuracy maintained across tens of thousands of units over years of war. And this was where Japan could not compete. The Arisaka rifle remained durable, accurate, and reliable. But it belonged to a different era, a time when rifles were built one at a time, slowly, proudly, by skilled craftsmen. The Garand belonged to a new era, where rifles were not crafted, they were engineered, and in that transformation lay the true strategic difference between American and Japanese small arms capability. The Garand was not just a superior weapon, it was the physical proof that Japan was fighting a modern war with pre-industrial tools, and no amount of bravery could bridge that gap. By August, internal memoranda began acknowledging what the evaluation team had discovered through months of comprehensive analysis. Japan's small arms technology had fallen a generation behind American weapons development, not through inferior engineering understanding, but through industrial limitations that prevented implementation of known solutions. Japanese designers understood semi-automatic rifle operation as thoroughly as their American counterparts. They could draft designs equivalent to the Garand in theoretical capability. But theory meant nothing when factories lacked the machine tools for precision manufacturing. Steel mills could not guarantee alloy consistency, and quality control procedures had been simplified to maintain production volume at the expense of dimensional accuracy. The captured M1 had illuminated problems that required industrial infrastructure Japan no longer possessed and could not rebuild under wartime conditions. The psychological burden on the evaluation team manifested in subtle changes to their technical reports. Documents that had begun with optimistic assessments of potential improvements gradually evolved into clinical catalogues of Japanese manufacturing inadequacies. Engineers who had expected to extract competitive advantages from the captured rifle instead found themselves documenting the extent of their nation's industrial disadvantage. The Garand had become physical evidence of the gulf between American manufacturing capability and Japanese production reality, proof that modern warfare rewarded industrial capacity as much as tactical skill or strategic vision. Field reports from Japanese infantry units engaged in combat against American forces provided devastating confirmation of what the arsenal testing had revealed. Soldiers described firefights where American troops maintained continuous semi-automatic fire that pinned down entire Japanese platoons. Individual American riflemen could suppress Japanese positions that would have required multiple bolt-action shooters to neutralize. The sound signature of Garand fire, the rapid mechanical cycling that never paused for manual bolt operation, had acquired psychological impact that transcended the weapon's technical advantages. Japanese infantry learned to recognize the distinctive rhythm of M1 fire as a harbinger of overwhelming firepower they could not match with their Arisakas. The captured rifle explained the source of this dominance. With engineering clarity, Japanese soldiers in the field had experienced viscerally. Production priorities began shifting in response to the Garand analysis, as Japanese military planners recognized that infantry small arms represented an insurmountable disadvantage. Resources were redirected toward weapon systems where Japanese industry might achieve competitive parity, machine guns, mortars, and grenades, where manufacturing requirements aligned more closely with available capabilities. The implicit acknowledgement in this strategic adjustment was sobering. Japanese arsenals could not produce rifles comparable to the Garand, so Japanese infantry would have to rely increasingly on weapons that could be manufactured despite industrial limitations. The M1 had demonstrated that some technological gaps could not be bridged through determination or tactical innovation. Industrial capability established absolute boundaries that Japanese forces would have to accommodate rather than overcome. By autumn 1943, the captured Garand had been thoroughly analyzed, comprehensively tested, and exhaustively documented. The rifle remained at Kokura Arsenal, a monument to American manufacturing sophistication and Japanese industrial limitation. Engineers who had spent months examining every aspect of its construction returned to their regular duties with intimate knowledge of capabilities Japanese forces would never possess. The weapon that had promised insights into American ordnance development had instead provided uncomfortable clarity about Japanese obsolescence in small arms technology. Knowledge without implementation capability had proven worse than ignorance. At least soldiers who did not understand the extent of their technological disadvantage could maintain illusions about tactical solutions to strategic problems. The evaluation team now understood that no amount of training or doctrinal innovation would overcome the firepower gap between the Arisaka and the Garand. They possessed complete technical knowledge that only emphasized the hopelessness of their situation. The captured M1 had revealed not just American engineering excellence, but the comprehensive industrial ecosystem required to transform designs into mass-produced weapons that functioned reliably under combat conditions. Japanese arsenals lacked this ecosystem and could not rebuild it while fighting a losing war across the Pacific. The rifle that should have illuminated a path to competitive parity had instead confirmed that such parity was impossible under any circumstances that existed in 1943. Japanese infantry would continue facing American riflemen equipped with superior weapons, fighting with obsolete Arisakas because their nation's factories could produce nothing better given the constraints of degraded manufacturing capability and disrupted supply chains. The strategic implications extended beyond individual weapon performance to fundamental questions about Japan's ability to continue prosecuting the war. If Japanese industry could not match American small arms technology even when granted complete access to enemy designs, what hope existed for competing in more complex weapon systems like aircraft, tanks, or naval vessels? The captured Garand represented a data point in a larger pattern of technological and industrial disadvantage that permeated every aspect of Japanese military capability. American forces wielded not just superior rifles, but superior everything. Advantages rooted in manufacturing infrastructure that Japanese industry had never possessed and could not develop while simultaneously supporting military operations across thousands of miles of Pacific territory. Colonel Nambu's final comprehensive report on the M1 Garand evaluation, completed in October 1943, concluded with stark assessment that few, beyond senior military leadership, would ever read. In measured language that understated the severity of his findings, he acknowledged that Japanese small arms had become obsolete, not through design failures, but through industrial limitations that transcended engineering solutions. The captured rifle had provided complete technical knowledge, while simultaneously proving that such knowledge was insufficient without manufacturing capability to implement it. American ordnance engineers had developed the Garand, assuming access to precision machining, quality metallurgy, and rigorous testing as routine resources. Japanese designers, constrained by degraded industrial capabilities and dwindling wartime resources, could only observe the technological advantages of the M1 Garand, without any realistic hope of replicating them. It was not merely a matter of lacking blueprints or technical understanding. Those, in time, could be deciphered. The true barrier lay in the industrial reality of wartime Japan. Insufficient steel refining capabilities, inconsistent machining tolerances, production lines incapable of high-volume precision manufacturing, and a military doctrine that still favored spiritual resilience over technological innovation. These constraints were not temporary deficiencies, but systemic limitations that shaped every decision Japan made regarding infantry armament. The Kokura Arsenal Report, compiled after months of studying the captured American rifle, concluded, reluctantly but firmly, that Japan lacked the necessary industrial infrastructure to mass-produce a reliable semi-automatic rifle. It recommended continued production of the Arisaka series, despite acknowledging its obsolescence, for one simple reason. Japanese arsenals could manufacture bolt-action rifles reliably even under strained wartime conditions. Bolt-action firearms required simpler machine tools, lower-grade steel, and fewer precision components. They could be assembled with broader tolerances, meaning that they worked even when produced by factories suffering from material shortages, skilled labor deficits, and rushed production schedules. The Garand, however, required exceptionally fine tolerances. Gas ports machined to exact specifications, heat-treated steel that resisted deformation under high pressure, and a production system capable of holding micron-level consistency across hundreds of thousands of identical rifles. Japan simply did not have that capability. And so, for the first time in the war, Japanese weapons designers formally acknowledged what many had suspected, but few dared admit. Their infantry would fight the remainder of the war with rifles a full generation behind American equipment. This was not just a technical admission. It was philosophical defeat. The captured weapon had forced the truth upon them with irrefutable clarity. Modern warfare rewarded not only courage, discipline, or tactical brilliance, but also industrial sophistication. The Garand was not superior merely because it fired faster. It was superior because it embodied an economic system capable of thinking decades ahead, planning large-scale logistics, and integrating science, metallurgy, engineering, and mass production into a single doctrine. In short, it represented a nation that understood war differently. Within the walls of Kokura Arsenal, engineers spent months studying the rifle, documenting every dimension and mechanism, recording every heat treatment layer, and analyzing each metal component under microscopes. But their findings became increasingly disheartening. Replicating the Garand would require more than just knowing how it worked. It would require access to alloys Japan could not make, machining tools Japan did not possess, and industrial practices that were years, perhaps decades behind. Even if they could build one, they could not build 100,000. Even if they could build 100,000, they could not maintain them in jungle climates, supply the ammunition, or train troops to operate them effectively in large numbers. The Garand was not a weapon Japan could copy. It was a weapon Japan could only learn from. And so, the report did something remarkable. It did not recommend pursuing a Japanese equivalent. It did not propose prototypes or even experiments. Instead, it quietly advised against attempting to develop a semi-automatic rifle during wartime. It urged Japan to accept its technological position and focus on producing what it could: Arisaka rifles, bayonets, ammunition, and light machine guns, reliable, simple, and fundamentally outdated. This became, perhaps, the most significant moment of institutional honesty in Japan's wartime weapons development effort. For the first time, engineers and officers admitted that determination, patriotism, and discipline could not compensate for insufficient machine tools, industrial capacity, or metallurgical expertise. The rifle had revealed a truth that could not be unseen. Victory in modern war belonged not just to the bravest soldiers, but to the most advanced factories. The M1 rifle remained at Kokura Arsenal through the war's final years, preserved not as a prize, but as a reminder. Engineers occasionally revisited it, not to replicate its design, but to study its manufacturing quality, its material composition, its corrosion resistance, and its assembly methods. They were no longer trying to copy it. They were trying to understand the industrial philosophy behind it. As the war dragged on and Allied bombing crippled Japanese factories, the Garand remained in its storage cabinet, untouched. But it had already done its work. It had changed minds. It had planted seeds that would not bear fruit until peacetime. But seeds, nevertheless, seeds of industrial reform, mass production strategies, standardization, and quality control, concepts that would later define post-war Japanese manufacturing in automobiles, cameras, and electronics. After Japan's surrender, many of the same engineers from Kokura would go on to consult in rebuilding Japan's industrial sector. They remembered the Garand. They remembered how it represented not just engineering, but process, how it showed them the importance of tolerances, standardization, supply consistency, and technological planning. These lessons, born from wartime analysis, but refined in peacetime, helped transform Japan from a nation of skilled artisans into a nation of disciplined industrialists. The irony was profound. The rifle that could never be copied had instead taught Japan how to build things better. It did not shape their wartime weapons. It shaped their post-war industry. But during the war itself, the rifle remained silent, its lessons understood but unusable. Japan lacked the time, resources, and industrial foundation to act upon what it had learned. The M1 Garand served primarily as a reminder of a technological gap that could not be bridged by spirit, bravery, or tradition. A reminder that modern warfare was as much about factories as it was about soldiers. A reminder that winning a battle required more than courage. It required machinery, precision, and the ability to build the future. In the end, the most valuable thing the Japanese learned from the Garand was not how it functioned. It was why it existed, why a nation would spend years designing, refining, testing, and standardizing a rifle before a war even began, why it would prioritize logistics, ease of maintenance, and durability over individual craftsmanship, why it would invest not in elite weapons for elite troops, but in excellent weapons for ordinary soldiers. The Garand was more than an automatic rifle. It was the physical manifestation of industrial foresight. And foresight was something wartime Japan did not possess. When the war ended and Japan began rebuilding, the rifle remained at Kokura, later transferred to the archives of the new Japan Self-Defense Forces. Occasionally it was displayed for instruction, not as a weapon, but as a lesson. On the placard beneath it were 5 simple words that captured everything it represented. Technology is doctrine. Doctrine is destiny. In those 5 words was the story of a weapon Japan could never copy, but could never forget. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.